So we are going to discuss about topic nucleation. So first of all, what is nucleation? So we know there are three phases. So one is liquid, solid and gas. So there are three phases and there will be phase transformation between these three phases. Liquid to solid, solid to gas, liquid to gas. There are many phase transformations. So whenever there will be phase transformation, the nucleation will occur. So phase transformation has two stages. One is nucleation and the another stage is growth. So nucleation, the best example in our daily life is the transformation of water into ice. So nucleation is defined as the first formation of a new phase. The first formation of a new phase is called nucleation, and the growth increase in size of the nucleus formed during nucleation. So let us take liquid. This is liquid and this is solid of radius r. So let us take this example of phase transformation from liquid to solid. So here the solid is the nucleus. So if we observe, the formation of this solid nucleus will be the first stage for the whole transformation of liquid into solid. So later on this solid keeps on increasing its size and the growth will take place. And remember, this growth will be in the perpendicular direction for the solid. So what will be the first radius of this solid? Let us see. So here, if we check, Js will be the Gibbs free energy per unit volume of solid, and Gl is the Gibbs free energy per unit volume of liquid. Let us assume density of liquid is equal to density of solid and there will be no change in the volume of the whole liquid. So delta Gf, the Gibbs free energy change will be volume 4 by 3 pi r cube Gs minus Gl. Here Gl will be more than Gs, so this whole term will be negative. But during the formation of this solid nucleus, at the interface of this liquid and solid, there will be associated energy and that will be the surface energy. So here another term is 4 pi r square gamma, where gamma is energy per unit area of the solid liquid interface. Here by nature we can say it is positive. So if we take this equation in graph, this term, negative term, so it will be downwards, and this will be positive. This is 4 pi r square gamma, and this is 4 by 3 pi r cube gs minus gl. So if we represent the whole equation delta gf in graph, this will be like this. So at smaller radius, this will be positive, and later on increasing the radius, at the delta gf will be negative. So at one point, the delta gf will be maximum, and the radius at the delta gf maximum is known as r star, which is known as critical radius. So for the radius less than critical radius, the delta GF is increasing, which is thermodynamically not favorable, and for the radius above critical radius, the delta GF is decreasing, where the growth is possible. So for R less than R star, R increasing as delta GF increases, so where growth is not possible. And for R greater than R star, delta GF decreases as R increases. So in this case, the growth is possible. So R star will be critical radius for nucleation. So as the critical radius is at GF maximum, we can obtain the R star expression by differentiating the GF and equating it to 0. So we know delta GF equal to 4 by 3 pi r cube gs minus gl plus 4 pi r square gamma. So when we differentiate with respect to r, 4 by 3 r square gs minus gl 8 pi r gamma equal to 0. If we simplify, pi will cancel, and one of the r will get cancelled. This is at r equal to r star. So 4 r star gs minus gl plus 8 gamma equal to 0. So r star will be equal to minus 2 gamma by gs minus gl. So this is the expression for critical radius, and this gs minus gl will be the driving force, which is inversely proportional to r star. So more the driving force, smaller will be the radius. So whenever the driving force is more, the radius will be small, and it is easy for nucleation to take place. Nucleation rate. It is represented by letter I, and the units are meter per meter cube per second. So nucleation rate is defined as number of nucleation events per unit volume per second. and there is a growth rate which is represented by capital G, and unit is meter per second. Growth rate is defined as rate of increase of the size of growing particle. So let us represent the nucleation rate and growth rate in a graph. So y-axis is temperature and x-axis is time. So this is growth rate and this is nucleation rate. So if we observe, nucleation rate is dominant at low temperatures and growth rate is dominant at high temperatures. So note this point. Nucleation rate is dominant at low temperatures and growth rate is dominant at high temperature.